Hello everyone, I am Monika Bhushan and today we are starting the topic differential equation. So in today's class we are going to understand the basics of differential equation, what is differential equation, how to find its order, how to find its degree and all. Okay, so before jumping to differential equation, let us understand what is equation. So equation is some statement which gives us that something which is called as left hand side equals right hand side. Okay, so it says that equation always contains this equal sign. So here the mathematical equation contains mathematical expressions. So this is expression which is present in left hand side, even expression present in right hand side. So expression is what? That it makes some numbers are given to you. Okay, some positive, negative, any number will be present, some symbols will be present and some operators will be there. So these things all together make mathematical expression. So equation is the statement where left hand side, right hand side both have mathematical expression. And if I'll give one example, suppose 7x squared plus 9y equals 0. Okay, so 0 is also one expression, correct? This is nothing but the number, and even this is number, symbol and operator and all those things. So this is your expression, and left hand side, right hand side and equal sign makes equation. Now come to differential equation. What makes the equation very specific, which we call as differential equation? So here is the definition given for differential equation. So differential equation is an equation containing a function with one or more of its derivatives. Okay, so what does it mean? So with the help of this example, we'll understand what is differential equation. So here it is written 17y plus 7 by 2 dy by dx equals 6x. Okay, so we can see that this left hand side is nothing but again one expression, right hand side is expression, but in differential equation we must be having a function with one or more of its derivatives. Okay, so this y, we can imagine that this y is a function, y is a function of x, okay, and this dy by dx is its derivative. So this is derivative. So derivative is what? Derivative is rate of change of function. So whenever we talk about derivative, it is very important in practical use also. So this gives us the idea that why we need to study differential equation. Suppose in day-to-day life, we want to study the rate of change of climate, rate of change of temperature, change of weight or those things, then we have to actually deal with differential equation. So if we say this y is function of x, how this is function of x? This y can be written as fx. Okay, so this y we can write as fx, and this dy by dx we can write as f dash x. So f dash x or dy by dx both are same. So this derivative is rate of change of this function with respect to x. This complete term is nothing but my differential equation. And something again important point what we are going to make is this x is, if you see this x, so x is independent in nature. So we can say that x is independent variable and y is what? Y is dependent on x. So y will be, y is dependent. So why we are saying x is independent and y is independent? This y actually depends on x, and x is arbitrarily chosen any variable, and y depends on x. Y varies with respect to x. You must have seen dv by dt, where v is velocity and t is time, is nothing but acceleration. That means rate of change of velocity is acceleration, where time is independent. Okay, time is independent in nature and velocity depends on time. So rate of change of velocity is acceleration, which we always we have studied it. So similarly we can study these things in more practical applications also. Okay, so now we will understand how to find order of differential equation and how to find degree of differential equation. So as the formula given, that to find order of differential equation, we search for highest derivative of differential equation. We understood what is differential equation. Differential equation will contain the function and it will contain one or more derivative. Derivative is d by dx of y. Suppose we are talking about y with respect to x. So highest derivative will be what? This is suppose dy by dx. If I'll say that d2y by dx square, and in equation if it contains both derivatives, right? This is also one derivative, this is also one derivative. If both derivatives are present, which one is higher? So d2y by dx square is higher. And how this is higher than dy by dx? So how to find d2y by dx square? This is nothing but d by dx of d by dx of y. Correct, twice you are doing it. So this is this derivative is higher than this dy by dx. So this way we search for highest derivative in differential equation, and that will be called as order of differential equation. Now, so finding of order of differential equation is much easier than finding degree of differential equation. So this degree sometimes becomes a little tricky, because in all differential equations we cannot find degree of differential equation, because we have some rules. We'll see those rules. So degree in all differential equations cannot be defined. If it is defined, we'll find out. And how to find degree of differential equation? So power of the highest derivative of differential equation will be degree. Okay, so now to understand that degree to be defined, we have something written here, that the differential equation must be a polynomial equation in derivatives for the degree to be defined. We can find order in each and every differential equation, but to find degree of the differential equation, it should be polynomial equation in derivative. Okay, what does it mean? So we know, right, the property of polynomial equation. What is polynomial equation? So the equation will contain the powers. Like one example, if I'll give some polynomial expression is suppose a n x raised to n plus a n minus 1. Also you can write minus 2, anything, right? X minus 1 or some. This is something general equation, right? Expression. Now x raised to 0. Suppose x raised to 0 is nothing but this is what? This is 1. So if this is given to us, so this is polynomial in nature. Why? Because the power of this variable, this power of this x is always, this will be your positive numbers. It won't be negative. And the second thing is, it won't be fractional. It won't be fractional in nature. So my equation should be the differential equation. There the derivative should be polynomial in nature. So that means the power of your derivative should be non-negative, right? So it should be non-negative. And the other thing is what? It should not be fractional. It should be non-fractional. Okay, so these powers are if present in my derivative. So we will see that this is polynomial in nature, and then we can find the degree of it. And something more is there, that the derivative should be independently present. We'll see what does it mean. Okay, so we have the set of question. So find order and degree of the following differential equations. So very first question is, this is d3y by dx cube square plus y equals 0. Okay, so we have seen the definition of order, we have seen the definition of degree. Now we are just going to apply it. So in this equation, right, this is the equation and this is the derivative, this is the differential equation. We can see that one function y, you can think of this is your fx. one function is present, even the derivative of this function is present. So only one derivative is there. So the definition of order is what? In this differential equation, the highest derivative will be the order of differential equation. Eventually in this question only one derivative is present, correct? Only one term contains derivative, and this derivative is what? d3y by dx cube. Okay, so you can see that this is d3y by dx cube. So this is the derivative of this order 3. So you can say that the order of this derivative is, order of this differential equation is 3. So always remember that first we have to find order, and once we find order, then only we can find the degree of differential equation. So always first find order and then you have to find the degree of differential equation. Another important point is order will be found in each and every differential equation, but to find degree we have to see whether the it should be polynomial in nature, first thing. Second thing is it should, all derivatives should be independently present. Okay, we'll see what does it mean. Now, second question. So this is what we found, that what is the order and what is the degree. Degree is power of highest derivative. So in this question only one derivative is there. So this is the power of this derivative is 2. So we'll say that the degree of this differential equation is 2. Okay. The second question says that this is x d2y by dx square cube plus dy by dx power 4 plus y cube equals 0. So first of all, whether the given equation, yes, this is the equation, whether the given equation is a differential equation. So yeah, we can find that function and its derivatives are also present. So this is your differential equation. Now, to find order, what is the definition? Definition says that the highest derivative in the given differential equation will be the order. So what is the highest derivative? Here you see that this is your d2y by dx square. First term contains, second term contains dy by dx, and third term, even this right hand side, doesn't contain any derivative. So among these two derivatives we have to find which one is higher, which one is the highest derivative. So this is d2y by dx square and this is just dy by dx, or you can say that this is what? This is y double dash and this is y dash. So y double dash will be your, this is your highest derivative. So we'll say that the order of differential equation is 2. So order of differential equation is 2. Once we found this order, then we'll move to find this, what is the degree of differential equation. So degree of differential equation is what? So you don't have to search any other term. Whichever is your highest derivative, just find out the degree of it. What is the power of this highest derivative? That will be your degree of differential equation. You don't have to compare 3 with this 4. Why? Because this 4 is higher than 3, that is okay, but this 4 is power of what? This power of dy by dx only, and we have to see the power of highest derivative. So roughly, whenever you have to find degree, you don't have to bother about other terms. Just see which one is your order, which one is your highest derivative, and just see that what is the power of that. You don't have to see here and there. So the power of highest derivative is 3. So the degree is 3. Okay. Now come to the third question. So the third question is given as this is x by 2 d2y by dx square power 3 plus 3 sine y into dy by dx equals d2y by dx square power 4. Okay, so yes, this is the differential equation, and now we'll first find out the order, then we'll find out if we can find degree, then we'll find out degree. So what is order? We know that the highest derivative of the differential equation. So first term contains derivative. This is d2y by dx square. Second term is also containing the derivative. This is dy by dx only. This is y dash. This is y double dash. And right hand side also contains derivative, and this is again double dash, y double dash. So which one is the highest derivative? We see that the first term, even the right hand side, also contains d2y by dx square. Now, so to say order is 2. order is 2 because this is 2, this is 1, so order is 2. So what is the degree of differential equation? Here the power is 3, here the power is 4, and my definition says that the power of highest derivative. So the power of highest derivative is 3 also, power of highest derivative is 4 also, so which one we have to select? So the definition which I have given in that slide was very basic. Actually, if we'll go towards more refined definition, so the degree of differential equation is highest power of highest derivative. Okay, highest power of highest derivative is degree of differential equation. So the degree of this differential equation is 4, not 3. Okay, now we'll see some more questions. So this question is 1 plus dy by dx whole square and the whole is under root equals y into d3y by dx cube. So what we have to do? So always remember that whenever this type of question you will find as differential equation, that means if the power is not integral, right? The power is fractional here, and we had seen that it should be polynomial in nature. Here, if we will remove this under root, so this is nothing but this complete power 1 by 2. So we always make the power as non-fractional. Okay, so how we will rewrite this question? So I'm just going to rewrite this question with integral power. It will be 1 plus dy by dx whole square. This is 1 by 2, exactly correct. This is 1 by 2, and this is right hand side is what? Y d3y by dx cube. Now what I'll do, I'll square out both sides, left hand side and right hand side. I will square out. So what will happen? This 2 and 1 by 2 will get cancelled. So you can rewrite the left hand side will be how much? 1 plus dy by dx whole square, correct? Half and 2 has got cancelled, and this is nothing but you are squaring it out. So this is y square d3y by dx cube and square of it. Okay, so now you just I've done nothing. I've just rearranged it. I've just made the fractional power into non-fractional power. So this is 1 plus dy by dx whole square equals y square into d3y by dx cube power 2. Okay, so now what will be the order? So to find order, the highest derivative is d3y by dx cube. So the order is 3. How to find degree? To find degree, don't see those other terms. Just see which one is having highest derivative. Highest derivative is d3y by dx cube. So the power of highest derivative is 2. So 2 is nothing but the degree of this differential equation. Okay. So now the next question is what? Next is sine of dy by dx equals x by 2 plus y square. Okay. So now we'll come to the definition of differential equation. What we had said that my differential equation, we can find order of differential equation in each and every cases. But to find the degree of differential equation, the all derivatives should be independently present. This dy by dx is not independently present. This is the derivative, that is okay. Functions are also there. So this is the example of differential equation, that is 100% okay. And the order is what? The derivative, you will find that only one term is containing derivative. There is no derivative present here. So this is dy by dx. So d1y by dx1, whatever you say. So the order is 1. Fine, order is 1. But can we say that the degree is 1? No, we cannot say that the degree is 1. We'll say that the degree is not defined in this differential equation. And the reason is the derivative is not independently present. So what will be your some more refined definition of differential for the degree? That all those derivatives, so derivative should be independently present. First thing, it should not be under any trigonometrical function or logarithmic function. Then it will be then you will be able to find the degree of it. Okay, so here the sine dy by dx is not allowed, and this is not exactly same of sine x. Suppose sine x into dy by dx. No, you can't say that this is same as this, correct? No, because this is sine of dy by dx. So sine of dy by dx, if it is present in this case, or if somewhere it is written log of dy by dx, so this dy by dx is not independently present. They are inside logarithmic function, they are inside trigonometrical function. So we'll say that in these scenarios the degree will not be defined. Okay, so we'll say degree is not applicable, not defined, or whatever. Fine. Now come to the next question. So next question is what? Okay, now tell me that here also we find some sinusoidal function. So trigonometrical function is present. Can we say that we can find degree in this equation? So the equation is containing function, the equation is containing derivative. This is the differential equation, that is okay. First thing is to find order, right? Always we first find order, then we find degree. So how to find order? We'll just count that how many derivatives are present. So this term also contains derivative, this term also contains derivative, and this is dy by dx, this is d2y by dx square. So straightforward, the order is 2. So order is 2. Okay, now what is the degree? So we had seen here sine, we said that this is degree cannot be defined. Here also we have sine, but this sine is not as this sine, correct? This sine is sine of x square. That is okay. Sine of x square is okay, but sine of d2y, suppose d2y by dx square was not okay. So if this was the scenario, then we could have said that degree cannot be defined. But here what is happening? This is sine of x square. I don't worry about it. I mean, right, this is sine x square or sine y or sine v. I don't worry about it. I just have to see that the highest derivative is where? This is my highest derivative, fine. And this highest derivative is 2. And the degree of this derivative is 1. So degree is 1 of differential equation. Fine. Now the last question is log d3y by dx cube equals dy by dx plus y d2y by dx square. Okay, this is exactly same scenario what we had seen here. The highest derivative is d3y by dx cube. That is okay. So highest derivative is 3. So the order is 3. But the derivative is not independently present. This is log of d3y by dx cube. So we'll say that degree cannot be defined. Okay, so finally what I'll say, that every differential equation must have an order, but its degree not necessarily be defined. We had seen that those conditions when we cannot find the degree, right? And the other thing is degree of a differential equation is defined as the highest power of the highest derivative, where the equation is expressed in such a way that each derivative is present independently. Then only we can define the degree. Okay. So if you find this class useful, please like and subscribe my channel. Thank you.